Okay, so second part of graphing we're going to look at this week, we're going to do two transformations today. These are going to be what we call amplitude and vertical shifts. All right? You're going to see that the arithmetic today is a lot easier than yesterday. We're not going to really have to deal with fractions with pi in them. Okay? We're going to have to deal with those again tomorrow. But today you're going to see it's a little bit easier. All right, so basically the height of a sine or a cosine wave is called the amplitude. And I'm trying to show you a picture right here of what the amplitude is. So the amplitude is basically a distance. If you put a center line right through the middle of the wave, it's the distance from that center line to the peak, or from the center line to the low point. The wave is symmetrical. That's called the amplitude. Now, amplitude, I said it's a height. So if the amplitude is a height, what kind of number does that mean it will always be? Yep. It is going to be on the y-axis, so it's going to affect the y values when you do a transformation. But I'm just thinking about like the type of number itself. Think about heights. Heights are always what kind of number? Can anybody think about a number that, if I told you this number, there's no way it could be a height? Because, yeah, negative numbers can't be heights, right? So there's no such thing as negative amplitude. Okay, amplitude is always positive. So, one thing we have to be able to do is look at an equation, and I'm just going to skip ahead a couple slides to show you one. You've got to be able to look at that and know that that's an amplitude change. Okay? There's something about it. Two things. What operation are you doing? You look for that, and then you look for where you're doing it. The answer to those questions yesterday was the operation was always addition or subtraction. Where was it? It was inside parentheses next to the x. Okay? Today it's going to be a little different. So an amplitude change has this form. This is what an amplitude change looks like. It's when you multiply by a number in front. Could be sine or cosine, doesn't matter, either one. But if you multiply, that's the operation you're looking for, and where you're looking for it is in front. If you multiply in front, that's an amplitude change. Okay, so let's, what I'll do is I'm going to graph this on the calculator. I'm going to graph sine x, and I'm going to graph 3 sine x. So you can see the difference. Okay, so I already got sine x. Let's do 3 sine x. Let's see what it looks like. So that's the original, okay, between -1 and 1. What the 3 sine x does is it triples the height, triples the amplitude. So now it's not going between -1 and 1, it's -3 to 3 now. And if I were to play that sound, if I played the sound in blue, and then I played the sound in red, what do you think the difference would be?
The red would be a lot louder.
Yeah, the red would be louder. It's a louder sound. So I can do that after, but the only thing you're going to hear is just something getting louder and quieter. That's all it is. Okay. This one a little different. There's a -2 cosine x in front. So I said to you, amplitude is a height, so it's always positive. Well, this 2 and this negative are doing two separate things. Okay, if you just graph the 2, it would make the wave a little taller, but not as tall as putting a 3. But then the negative does something else. Does anybody know what happens when you put a negative in front? What it causes your graph to do?
They get closer together?
It's not going to get closer together. We're going to see, like, you mean left and right, like squishing it together? Yeah, we're going to see that tomorrow when we do the last transformation. But anyone have another guess what a negative would do? Yep. It flips it, right? And that's true no matter what you graph. It doesn't matter if you graph this or you graph a parabola. If you put a negative in front of something, it flips it. Okay. Let me show you that with something simple. Here's a parabola, just a U shape. If I put a negative in front of it and put in exactly the same thing, it just flips it. It's upside down. That's exactly what's going to happen when you put a negative in front of a sine function. Here's sine. Now let me put in a negative. So there's your original. And now take that and flip it. And there's the picture. So when you flip it, the high point, or what was the high point becomes the low, and what was the low point now becomes the high point. Now, if you just looked at that, what does that look the same as? Because I flipped it to get that picture, but anybody think of something else you could do to get that same picture?
Slide it over.
You could slide it over. You don't know which way it is unless you can see the formulas. But we could have gotten this same picture yesterday by taking the graph in blue and sliding it to the right. Right? Two different transformations can look exactly the same when you just look at the picture. Right? But they're totally different. All right? So keep that in mind. When you see a negative and a number, two things happen. Two separate things. Okay. What do you think would happen here? We're multiplying by a number in front, but this time it's a fraction. So we saw what happened when we put like a 3 in front. How about putting like a 0.5 or 1/2, same thing?
They get shorter.
Yeah, it's gonna compress. Okay. So now if I graph sine x, I'm just gonna put 0.5 because it's quicker for me to type in. Watch what happens. There's your original. There's 0.5. So if you compress it, that would correlate to a softer, quieter sound. Okay. Less amplitude. Okay. More amplitude, louder. So, this is a kind of thing where I can ask you on the test to do something here besides graph it. What I can do is I can give you any problem like one of these and just ask you, what is the amplitude? No graph necessary. Just a number. That's the answer. All right. So if you want to know the amplitude, what you have to do is take the absolute value of the number in front. That is the amplitude. Because remember, amplitude is a height. It wouldn't make sense if you said to me the graph is -2 inches high. Can't have that, right? You can have 2 inches, but you can't have -2 inches. Okay. So let's just make another column right here and identify the amplitude of those three. Okay. What's the amplitude of the first one? 3 sine x. Yep. 3. Just the absolute value of A. What's A? A is the number that's right in the front. So the amplitude there is 3. Don't need a graph at all to do that. We're going to do graphs, but you don't need it for this. What's the amplitude of -2 cosine x? Yep.
2.
2. Now what if I did this? What's the amplitude now?
2.
Still 2. That negative has nothing to do with the amplitude. That negative has to do with flipping it. But when you flip something, it doesn't change the amplitude. And how about this one? 1/2 sine x? What's the amplitude there? Yeah, 1/2. Okay, so you'll have at least 2 questions on the test where all you have to do is look at the graph, look at the equation, and tell me the amplitude. Right? Now, what if I did this? What did I just do to that first one? We talked about this yesterday. That plus pi is I'm looking for the name of the transformation. Yeah?
It's a phase shift.
It's a phase shift. So now what I've done is I moved it to the right. So what's the amplitude? Yeah? Still 3. Doesn't matter if you move something left or right. You're not changing the height. The only thing that changes the height is changing that number right there. Okay? You can add all kinds of other stuff in there if you want, but that's the only thing that has to do with the height. Okay? So you got to know which number to focus on. So I already said this to you. Because we're taking absolute value, amplitude is always a positive number. So two different things can happen here. We're changing it up and down. Okay? Up and down. If the number in front is bigger than 1, that's going to cause your graph to stretch. If the number in front is less than 1, the absolute value of it is less than 1, then the graph will compress. Right. So numbers that would cause your graph to stretch, 3, 5, -8, -20. All those numbers would cause your graph to stretch. Numbers that would cause your graph to compress, 1/3, 0.7, -0.2, -1/2. So you want to think about it like on a number line. Anything in the blue zone is going to cause your graph to stretch. Okay, you're going to get stretch and stretch. With the blue zone on the left, bless you, you're also going to get a flip in there because it's negative. Okay? But anything in the blue zone causes stretching. Anything in the green zone, that's a compression. Anything between -1 and 1. Okay? On the left side of 0, in the left part of the green zone, you're going to get a flip in there too because it's negative. Okay? But that's when you stretch and compress. Okay, so now what we have to do is, we know what the equation looks like. We've got to figure out how do we take the original table from yesterday and modify it. All right. So, Stephen, what values are going to be changing today? If we're stretching and compressing vertically.
The y values.
The y values. Okay, the y values are going to be changing, so that means which ones are not changing?
X values.
The x values. So the x's are going to stay the same. And the reason it's really nice when the x's stay the same is because the x's are all the numbers that are a pain to deal with. They're all the fractions with pi. You don't have to deal with any of those today. The 0, the pi. In fact, I can tell you the answer to every x column for every problem we do in class and every problem you do in the homework tonight. It's 0, pi over 2, pi, 3 pi over 2, 2 pi. The x column never changes for these two things that we're going to study today. Now, think about the y column. That's going to change. What are the kinds of numbers we have in the y column? There are only 3 numbers we put there. Yeah?
1, 0, -1.
1, 0, and -1. So today, all you have to do is arithmetic of the number 1, the number 0, and the number -1. The arithmetic is much easier than what we had to do yesterday. Okay, just 1s, 0s, -1s. So, to find your new y values, all you do is multiply your old y values by a. Remember, a is the number in front. Notice I didn't say absolute value of a. Bless you. I didn't say absolute value of a. If there's a negative with the a, when you're doing the graph, you use the negative. Because the negative causes your graph to flip. You don't just ignore the negative when you're actually making a picture. Maybe you're allergic to absolute value. I don't know. I mean, it's not good, not a good lesson. So when you're graphing, don't ignore the negative. If it's there, use it. If it's not, then don't worry about it. Only time you ignore the negative is if I ask you, what is the amplitude? Don't give me a negative number for that. But the negative is very important when you're doing the graph. Okay, so all you're going to have to do is multiply a 1, a 0, or a -1 by whatever the number is that is in front. That's it. Okay, so let's look at an example. Okay, so now at this point we know two different transformations. Okay? We know what a phase shift is, and we should know how to identify it by looking at the equation. And we should now know how to identify an amplitude change. Obviously this is not a phase shift because we're not doing yesterday's notes again. This is an amplitude change. But can somebody tell me why that one is an amplitude change? Yeah. All right. Can you say anything else? He said it's being multiplied by 3. I could write something down that's being multiplied by 3. That would not be an amplitude change. You don't know that one yet, but I could do it.
It's in front of the cosine.
It's multiplying in front. Okay? Two things. The operation is multiplication. The where are you doing it is in front. That's how you know it's an amplitude change. So let's make our table. Remember, the table is worth 10 points. I don't want to see any decimals in the table, unless it's a decimal that ends. Like if it's 4.5, I mean, you can put 4.5. But if it has pi in it, you should not be putting 3.1415 or something like that. Leave it as pi. Don't ever round off pi. Okay. So Alyssa, what column here, since we know it's an amplitude change, is staying the same?
X.
The x. Okay. And my x's, Andrew, can you remind me what my x's are for every problem we do today?
Pi over 2, pi, 3 pi over 2, 2 pi, 0.
0 at the top. Okay. X's are going to stay the same because we are not doing anything today that involves left and right. Everything today is up and down, vertical. All right. So now, what I usually do is I put my answers in that box. I'm going to put the original values outside the box, just so I remember what they are. Brianna, do you remember for cosine what the original y values are?
1, 0, -1, 0, 1.
Yep, perfect. 1, 0, -1, 0, 1. Okay. And Sebastian, I'm going to take all of these old y values and multiply them by what?
3.
And that's it. So can you tell me what I would get for what?
0, -3, 0, 3.
That's it. That's your table for an amplitude change. Okay, so if you had that, you're going to get 10 out of 12 points for the problem. 1 point for each x, 1 point for each y. Any questions on the table? Okay, and on the test, I already have this table printed on the test, so you won't forget to do the table because it's printed right on the test. I should do that on a worksheet too. Okay, so now we can make our graph. Now, what's the highest and lowest that I go here?
3,
Right. So there's a few different ways you can do it. I'm just going to say on my y-axis, my tick marks go by 3s. That's how I do it. The reason I do it that way, I'll show you in a second. Okay, but there's a reason why I do it that way. Now, if I don't label these x's, I'm going to assume on the test that you've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 are not the x values you want at all. So label the axis with the x values you want. So we got 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, and now plot your points. So we've got 0, 3, right there. Pi over 2, we're at 0. Pi, we're going to be at -3. So right about there. 3 pi over 2, back up to 0. And 2 pi, back to 3. So remember, this is the middle of a wave. So it's not a V. It's like this section right here. So it should have kind of a curve to it. Okay, so it's gonna go like this, come down, and go back. Any question on that? That's your sketch. Now, if I wanted to sketch 5 cosine x, and I wanted to just make a sketch of it, all I would have to do is this. 5, negative 5. So today, a lot of my graphs are going to look the same. The reason they're going to look the same is because I'm going to change my scale. It's kind of a pain if you give me something that's like 30 cosine x, and I have to draw it 30 times bigger. Like I might go off the page. I'm not going to have enough space. So if you gave me something that big, I'm just going to change the scale like that. And now that's the graph of 30 cosine x. So you might notice that in your homework. All your graphs might look exactly the same tonight. And that's probably going to be because you're using different scales. Now, if you use the same scale on every problem, then all your graphs will look different, but you might run out of space. I might give you a real big one and it's not going to fit. So you're probably going to have to change your y scale. Any questions on the table or the sketch? Okay, let's try this one. 1/2 sine x.
Wait, we're gonna go back to those 5 steps and stuff. We're gonna go like 1
Are we going to go back to the what?
2. Didn't you say there were like 5 steps to finding?
5, well, you're finding the coordinates.
5, okay.
The 5, these are the 5 key coordinates.
I was like,
Yeah, so these are the 5 key coordinates. Okay, the reason we got to find 5 is because of the curve. Like if we were just graphing lines, all you'd have to do is find 2. Done. All right, so y equals 1/2 sine x. Courtney, can you tell me out of the transformations we've studied, which one that one is?
I know, I can't think of the word, but it starts with an amplitude.
It's an amplitude change. And can you tell me why?
Because you have the 1/2 in front of the sun.
All right, so it's in front, and what are you doing with it?
Well, now I want to say dividing, but before it was multiplying.
Well, that's still multiplying, right? If you were to read that, that's 1/2 times the sine of x. So you're still multiplying something in front by sine. It's just this time it's a fraction. But you can multiply by fractions. All right, so that's why it's an amplitude change. 1, you're multiplying. 2, you're doing it in front. If you're wondering, well, where else can you multiply? You could multiply right next to the x. We'll see that tomorrow. All right, so now let's make a table. All right, so Cal, what column stays the same when we do one of these?
X.
Yep, keep the x's the same. So if not yet, hopefully by the end of the week, you're going to start to memorize these. 0, pi over 2 pi, 3 pi over 2, 2 pi. Now don't forget why we use those. Right? These are all the quarter points of the cycle. 0, 90, 180, 270, 360. They're just 5 numbers that are equally spaced throughout the quarters of the cycle. Right? And that gives us a good graph. If you picked 5 points that were all bunched together, like 0 degrees, 5 degrees, 10, 15, 20, 25, or something like that, you'd have points like this. That wouldn't give you much of a graph, right? We picked 5 points that are nicely spaced throughout the whole cycle. That's why we use those numbers. Okay, so we got our x's. Matt, what are my y values for sine?
The original or the with the half?
The original.
1, 0, negative 1, 0, 1.
So if you did that, you'd be doing
That's
this
color
problem.
So it would be 0, 1, 0, negative 1, 0.
Yep. And now we take half of all those
Straight
numbers.
up the brain right there.
0, half. If you put 0.5 there, I'm fine with that decimal because you're not rounding it. 0.5 is 1/2. It's the same thing. 0, 1/2, 0, negative 1/2, 0. There's your table. Okay, 10 points for that. Questions on the table? Okay, so let's make the sketch. Okay, I can already tell you this is a sine wave. The segment that we sketch of a sine wave usually looks like that. That's just the way it works out. Okay? Cosine, we sketch more of the V part. Sine, we sketch kind of that S part of it. Just two parts of the same thing. So my graph is basically going to look just like this. It's just going to be an S shape. Just got to make sure I label the axes correct. So we got our x's. 0. If you don't label 0, that's fine. The axis is always 0. But you got to label everything else. Okay. And what's the highest and lowest that I need to go here? Half, negative a half. So, I mean, if you wanted, you could let this be 1 and negative 1 and just say a half is in the middle. Or you could just make the mark itself 1/2. That's fine. Right? And now do your y values. 0, half, 0, negative a half, back to 0. There's your graph. Okay, and remember, this graph goes on forever. It doesn't actually stop there. This is mostly for people that weren't here yesterday. But we are only sketching one section of it. If you wanted another section, this is all you'd have to do. Make a copy of it, and then just put it, I'm a little off, but you basically put it like that. So if you can sketch one section, you can sketch it forever. Just copy and paste what you did. Okay, but one section is all you need. Also, what's the name of that? I don't use the word section. There's a better word. What do we call one section? Yep.
Cycle.
A cycle or one period of the graph. Either chart. Okay, let's look at one more. And then we'll do our last transformation. Negative cosine x. So you might look at that at first and say there's no number in front, but technically there is. Yep. It's like having a negative 1. The negative and the 1 are separate. So is the amplitude here going to change? Not really, no. The amplitude's not going to change. But what is the negative going to do? I mean, if you took that negative out, it would be a different graph. So that negative is going to do something. Yeah?
It's gonna flip it.
It's going to flip it. Okay. So let's make our table. X's. We've got those values. 5 nicely spaced numbers throughout an entire cycle. And now take all your cosines, all the y values, and basically just multiply them by negative 1. So you're going to get negative 1, 0, 1, 0, negative 1. So cosine normally looks like this. It's kind of that V shape. That's going to flip over. So that's going to look more like a hill, okay, or like an N shape. Right? So 1, negative 1. And now put our x-axis. Pi over 2, pi, 3 pi over 2, 2 pi. And now we've got 0, negative 1. Pi over 2, we're at 0. Pi, we're at 1. Then 0, then negative 1. 0, negative 1. So it's still a wave if I kept going. Right? Still a wave. It's just been flipped over. Okay. You don't need the dotted part. Okay. So any questions on that? So not really an amplitude change, but it still falls under the same set of rules because it's like you're multiplying by a number in front. It's just the number in front was a negative 1. So the 1 doesn't change the height, but the negative flips it. Okay, so that's amplitude change. So the last transformation we're going to look at is a vertical shift. So out of the 4 transformations, there's 2 shifts, and then there's 2 stretches. Okay? We were stretching the graph up and down. That's an amplitude change. When we stretch things, we had multiplication. Multiplied by 1/2. We multiplied by 2 or 3. We're going back to shifting. We did shifting yesterday. What operation do you see when you do shifting? Addition or subtraction? Now you might say, well, we already did addition and subtraction. Isn't it the same operation? Yes, it is. It's where it is. Okay? Now you're doing addition and subtraction, but look where it is. It's outside the parentheses. That is not a phase shift because it's outside the parentheses. Now it's a phase shift. If you put the x and the number in parentheses together, that makes it a phase shift. Now, which way do you think this one would shift? It's vertical, so you got two options. Up to. All right? Now remember, we thought yesterday when we did plus, it would shift to the right, but it actually did the opposite. Plus shift to the left. So you still want to stick with up to, or do you want to change your mind?
Stick with it.
You want to stick with it? You sure I can't get you to change your mind?
Yeah.
Okay, good. Don't change your mind. So, sine of x plus 2. Let's graph sine of x and sine of x plus 2. Now, on my calculator, I have to close the parentheses so that it knows the plus 2 is not inside it. Let's see what happens. So there's the original. And there's the plus 2. Okay. This one doesn't do the opposite. It's what you would expect. Plus will shift up. Something like that would shift down. Okay, that's the difference. Okay, so now you know how to identify a vertical shift. The operation is adding or subtracting. Where is it? It is outside the parentheses. So technically you could do something like this. That's exactly the same as the one on the left. Right, what I basically did there is I used the commutative property. When you add two things together, it doesn't matter the order. Like if I did 2 plus 7, 7 plus 2, sine plus 2, 2 plus sine, same thing. All right. I usually like to put it at the end. Okay, I like it like this better. But technically that is the same thing. Okay, addition or subtraction outside the parentheses. All right, so now we'll summarize what we just said. Plus, if you see addition, it moves it up. If you see subtraction, it moves it down. And how much does it move up or down? Depends on how much you add or subtract. If you add 5, it goes up 5. If you add 3.5, it goes up 3.5. Okay, so last thing we have to think about to do the graph is we've got to think about what happens to the original table. Either the x's are going to change or the y's are going to change. I just showed you the two directions that we're moving. Based on those directions, what values in the table are going to change?
Y.
Yeah, the y's are going to change. That means the x's stay the same. Okay? We like when the x's stay the same. Makes things easier, makes the arithmetic easier to do. So, again, this is how to find the 5 coordinates. There's not 5 steps to this. There's only 2. It's how you're going to find the 5 coordinates we're going to do in a second. Okay, so step 1, x's stay the same. And if you forget, just think in your head, vertical. Okay, vertical means up and down. Which axis goes up and down? That's the y. So if you move something vertically, you're changing y's. You're not changing the x's. Now, this time the arithmetic is even easier to find the new y's. You don't even have to multiply. I mean, multiplying by 1s and 0s, it's still pretty easy. But this time, all you have to do is look at the number that's at the end. Okay, I called it D. It's the number that's right here. Look at what you've added or subtracted and do that to all the original y values. Don't do the opposite. Don't do the opposite. On every test, somebody always does the opposite. I'm not sure how I can draw your attention to it anymore. What happy faces. If you see plus d at the end, you're going to do plus. If you see a minus, you're going to do a minus. I know with phase shift it is the opposite, right? So you got to, on your reference sheet, just make a list somehow, right? Don't do the opposite when you're dealing with vertical shifts. Okay, so let's take a look at a couple examples with this one. Okay, so it's y equals sine of x plus 2. All right, now we know 3 out of the 4 transformations we're going to learn this week. We got to look at that and identify, is it the phase shift? Is it the vertical shift? Is it the amplitude change? We know it's a vertical shift because that's what we're learning. But can somebody tell me why that's a vertical shift? What makes it a vertical shift? Actually, 2 things. Yeah.
When you're going in order, so sine times x is going to come first.
Remember this, there's no multiplication here. Just like if you wrote something like this doesn't mean square root times 9. This just means square root of 9. This just means sine of x. So there's no multiplication in that equation. Any questions on that? This part right here is called the argument. It's just the number you're plugging into the sine function. But the operation is not multiplication. Just like here, 9 is the number you're plugging into the square root function. But you're not doing any multiplication to take the square root of 9. Square root is its own separate thing. Sine is its own thing. It's not multiplication. So anyone else tell me why that's a vertical shift? Yep.
You're adding 2 to the end of sine.
Yep, we're adding, tells you it's a shift. Where you're doing it tells you what kind of shift. It's outside the parentheses. Okay. Adding outside is a shift in which direction? Up or down? Up. Okay, let's make our table. Okay. Gabe, what are my x's going to be here?
For sine, it's going to be 0, pi squared, pi over 2, pi over 2, 2 pi.
Can you say that middle one again? That's fourth one?
3 pi over 2.
Yep. Okay, so there's my table. And now my original y values, 0, 1, 0, negative 1, 0. Alex, what am I going to do to all of those?
You're gonna subtract the, I can't remember the name of it. My mind's going blank. I'm trying to subtract the thing from
What are you going to subtract? You don't have to give me, can you just tell me specifically in this one?
it. To the y's?
Yeah, you said subtract.
So I can't remember. Kind of zoned out a little bit. Oh, no, I thought you were talking about the final y. You're talking about the plus 2 or the y.
I'm talking about the what? The final answers for y. Yep, I just want like the numbers I'm going to put right here.
Anti?
Why'd you change your mind?
I have no idea.
He went from subtract to add. Do we
No, because it's not inside the brackets, right? So it's, you don't flip it.
You don't find the opposite.
You don't do the opposite here, right? You do exactly what you see.
It's on that one time.
Don't do the opposite. Okay, so whatever you see, that's exactly what you do. So the directions say to find the new y's, you either add or subtract. You look at what you have. In this case, we have addition. So we're going to add that number to all the original y values. So Abigail, what number am I going to add here? 2. We're going to add 2 to all the original y's. 2, 3, 2, 1, 2. And those are your y's. Adding 2. Okay, so don't subtract here. If you do, well, you might still get your x's right, so I'll give you 5 points for that. But then you're going to get your y's wrong, so you're going to lose those. And then if you get the y's wrong, chances are your picture is going to be wrong too. So then you're going to lose 2 points for the picture. Okay. Any questions on the table? All right. So now let's make our sketch. What's the highest I need to go? 3. So leave enough room. We're going to start, I would say start at 0 and just go up to 3. That's plenty of space. Now if I had to go to like 20, then I might do like 0, 5, 10, 15, 20. Might go by 5s, but I don't really need to do that here. Okay, put our labels. Pi over 2, pi. 3 pi over 2, 2 pi. Now if I wanted, I could put those labels right up against the axis here because my sketch is going to be shifted up higher. Okay, I'm going to be sketching up in quadrant 1. Okay, I'm not going to go below the x-axis at all. So 2, 3, 2, 1, 2. 2, 3, 2, 1, 2. There's your sketch. Okay. Now, looking at that sketch, what's the amplitude of that graph? Yeah. No, not 2.
Is it 3?
No, it's not 3.
1, 2, 3.
It's what?
Like 1. Isn't it? Like from 1, 2, 3.
You only get a choice of one number.
Oh.
Yeah, you can't pick one. So look at the equation. Sine of x plus 2. We know what an amplitude change would look like. So when you see it's 1. Right? If you want to pretend like you're multiplying by a 1 in front, you can. There is no amplitude change there. Remember, amplitude is the distance from the center. There's your center. It goes 1 unit above, 1 unit below. It's always symmetric. Okay? 3, you could say, is the maximum value that it hits. That's the highest it ever goes. But there is a difference between the highest it goes and the amplitude. Okay? Amplitude here is only 1, but the highest is 3. Okay. Any questions on that? Okay, so let's finish up with a cosine. Okay, we did a sine shifted up. Now this is going to be a cosine shifted down. Right, so Megan, I know you weren't here yesterday, but we've done them a few times in class. Do you know what these x values are?
0, pi over 2, pi, 3 pi over 2, 2 over pi.
What's the last one again?
2 over pi.
Not 2 over pi, just 2 pi. Yeah, just 2 pi. Okay, so we got our x values. Now I need the original y values. If I don't know the originals, then I can't figure out the new ones. Because I got to take the old ones and shift them down 5. So I got to know where I'm starting. How about Madison? Can you tell me my original y values for cosine?
It's 1, 0, negative 1, 0, 1.
Okay. And now we're going to take all of those and Alex, what am I going to do to them?
You're gonna subtract 5.
I'm going to subtract 5. Nice. We're going to subtract 5 from all of them. So we're going to get negative 4, negative 5, negative 6, negative 5, negative 4. One thing I haven't told you, but a lot of times if you look at the y values in the cosine column, they're symmetric They read the same forward and backwards. Just that always happens because of how I taught you to do this. So -4, -5, -6, -5, -4. Okay. Questions on the table? Okay. So last thing, we make our sketch. This time, I made a grid because I'm going so far down. It's hard for me to see on the board without a grid. And I'm just going to go by ones. I'm going to put my labels right on the axis because there's no worry that I'm going to be sketching up higher. My sketch is going to be down in quadrant 4. So pi over 2, pi, 3 pi over 2, 2 pi. If you want 0 right there. Okay, so -4, -5, -6. -4, 5, 6, 5, 4. There's your sketch. Okay, and as far as the connection with sound, this is the transformation that I really don't have a connection with sound. Shifting a wave up or down, not really sure what that would do. Stretching it up and down would make it louder. Shifting it up and down, no connection. Okay, so we learned 3 out of 4. We've done period change. No, we haven't done period change. We've done phase shift, vertical shift, amplitude change. The last one we have tomorrow is the period change, and that goes back to stretching and compressing. But not vertical, we'll do horizontal. Okay. So we'll finish that up tomorrow, and that'll be it for what's on the test. Okay, so homework tonight will be a worksheet. I'll try to put it at the end of the video in case you lose it or you need it, but I'm going to give you the worksheet right now.